Let's compare the population mean to the mean of the sample means. Okay, that's a lot of words. So what is the population mean? Well, let's first write down the population again. So I'm going to write it down at the bottom here. Our population is relatively small. It only contains three numbers, the numbers 5, 8, and 12. And so because we have all the values in the population, we can calculate the population mean, which is noted by using that Greek letter mu. So to calculate this population mean, we can simply add up all the values in the population and divide by the population size, which is 3. And that gives us a population mean value of 8.33. And so now let's compare that to the mean of the sample means. So in this column here that I'm highlighting in red, these are all the different sample means that we can get when we randomly pick two numbers from that population that contains those three numbers, 5, 8, and 12. And so if I want to calculate the mean of the sample means, so the mean of sample means, the notation we use for that is mu sub x bar. That basically just means calculate the mean or the average of all of the sample means. So we can do that by adding up all these numbers and dividing it by 9. And so when we do that, okay, the mean of all the sample means, right, there, that's 5 times 1 plus 6.5, there's two of them, plus 8.5, there are two of those values, plus 8 times 1, plus 10 times 2, plus 12 times 1. And we divide all of that by 9, right? Hopefully you can follow along with me here and see that that also equals 8.33. So, whoa, it seems that the population mean is exactly the same as the mean of all the sample means. So this allows us to make the conclusion that when you have a sampling distribution of sample means, right, the mean of those sample means actually targets the population mean almost perfectly. In this example, when we have all the data, you can see here that the mean of our, let me use a different color, the mean of our sample means actually targets the actual population mean. So this is really useful in statistics because a lot of times the mean, I'll write it here, for the population, it's unknown. And so how can we estimate for that unknown? And one way of doing that is to get samples from the population and try to get as many samples as possible and then calculating the mean of all of our sample means, because it turns out that the mean of our sample means actually targets the population mean pretty well.